Hi viewers, I am creating these videos to help teachers of maths support their learners in making sense of mathematical concepts and their associated procedures and processes. And today what I wanted to look at with you is the idea of a prime factorization, or writing a number as the product of its prime factors. Now, before you do this, before you have a look at this, you may want to be familiar with factors and factorization of numbers, which is another video I put together, because I'm going to reference some of the content of that in here. And if you're not familiar with how we've approached that using the Cuisenaire rods, then this might not make complete sense to you. So I have my Cuisenaire rods here, and I want to use these to support how I go about finding the prime factorization of a number, let's say the number 18. So I want to write this as a prime factorization. Well, I already know that factorization, and particularly factorization into factor pairs, involves building rectangles. So what I want to do here is I want to build a rectangle that has a value of 18, that uses rods, assuming the white rod is 1, that have a total value of 18. And of course, there are a couple of different rectangles I could build. I could build, say, this one. That has a value of 18. I could build this one. That has a value of 18. I could build this one. That has a value of 18. I could get creative here as well, and I can build something like this. Which still has a value of 18. Okay, and as I mentioned earlier, the sort of in the facts and factorization video, we talked about the idea that it's about the width and the length of these rectangles. No matter how you build them, there are only really 3 unique rectangles for something like 18, and depending on the number, of course, depends on how many rectangles. But all of those rectangles will have a length and width that is either 3 by 6, 2 by 9, or 1 by 18. So these are showing the factors, and these are showing how you can decompose this number into the product of 2 factor pairs. Okay, so now that we have the factors and the factorization of 3 times 6, or 2 times 9, or 1 times 18, what I would say to learners now is, okay, can you take the length and width and build those using only prime valued rods? So if we first of all look at the 2 by 9, then we can see that I can build the width of this using a prime valued rod, a 2 rod, and I can build the length of this using a prime valued rod, the 3 rod. And you must put in, if you're going to work with this, you must put in the stipulation that they can only use the same rod along any one dimension. So I can use a different rod along the width as I use along the length, but along the length I can only use the same rod. So in this case, the 3 rod. Otherwise, what you might get is people building, say, like, for something else, you might have some people building 3 2s and a 3, or something like that. And that's not going to work here, because we need this to be a model for addition, for multiplication, not addition. Okay, so if we look at what we've got here now, then what we had originally, and I'm going to write this down here, what we had originally was a 2 by 9, and that 2 has stayed a 2, but that 9 I've replaced with 3 3s. And this is a model for multiplication, repeatedly adding the same thing. So this is 3 times 3. So I've replaced that 9 with 3 times 3. And of course, this is the prime factorization of 18. This is 18 decomposed into a product of its prime factors. And I can do the same thing here with the 3 by 6. So if I look at the 3 by 6, well, I can see that I can create its width using a 3 rod. And actually, I've got 2 ways to create its length. I could create its length using 3 2 rods, or I could create its length using 2 3 rods, and it doesn't really matter which one of those I use. So again, if I look at my 18, then I can say, right, well, I broke it down into a 3 by 6 rectangle. I built it using a 3 by 6 rectangle, and that 3 has stayed a 3 because it was prime. but this 6 has been replaced either with 2 times 3, 2 repeated 3 times, or 3 times 2, 3 repeated twice. But of course, it doesn't matter which one of those it is, I still end up with the same 3 primes. But then what about this one? What about this 1 by 18 one? Well, of course, 1 by 18, immediately I run into a problem with the width, because I cannot create that width using a prime valued rod. That's a width of 1. And so actually what that's telling me is that although I can factorize 18 into 1 times 18 using sort of a width of 1 and a length of 18, that this is not then going to allow me to look at this decomposed into a product of primes. And it's because of this 1. Because of this 1 is not prime, I've then just got to go with the 18, and I could carry on writing that as 1 times 1 times 18, 1 times 1 times 1 times 18 forever and ever and ever. So this is not a good start. And it's important for learners to recognize that. And it's important for learners to recognize, of course, that when this is the only decomposition, that the number is already prime. And so I shouldn't be using a 1 by rectangle unless the number is already prime, in which case that's the only one I can use. And actually, interestingly enough, this also works, this sort of idea and this way of making sense of things also works if you start with 2 composite factors. So let's take a number like, say, 24, and let's build it as a 4 by 6 rectangle rather than 3 by 8, because 3 is obviously prime. So let's take 24, and let's say I built this as a 4 by 6 rectangle. Well, then again, the same rules apply and the same logic applies. Can I find a single prime rod that I could repeat multiple times along the width? And can I find a single prime rod that I could repeat multiple times along the length? And of course I can. I can repeat this as 2 2s. So I can decompose that 4 into 2 2s. And then my 6 can either be 3 2s or 2 3s. But it doesn't matter which way around I put those, I will end up with the same pair of numbers. And of course, I could be showing this as a tree rather than just as a, successive decompositions here. I could be showing this as 18 or 24 becoming 4 and 6, and 4 becoming 2 times 2, and 6 becoming 2 times 3. I could show it in that way if I want to, but actually I found I don't need to when I'm using this. I've found that the tree sort of gets in the way because my learners are used to sort of seeing this as a multiplication, as the product of 2 factors. And then it's quite simple then to say, right, well, this 4 has now been replaced by a 2 times 2. So just underneath where the 4 was, I'm writing a 2 times 2. And this 6 has now been replaced by a 3 times 2. So underneath where this 6 was, I'm writing a 3 times 2 or a 2 times 3. And so now I've got my product of primes. So you can use a tree if you like, but I find when in doing stuff like this, actually you don't need to use the tree at all. So that is my short video on how I might look at prime factorization and writing a number as the product of its prime factors, and supporting learners in making sense of that and what's happening when I do that using the Cuisenaire rods. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for the website that allows me to bring all of these things to life. If you've never been to mathspot.com before, then please do. Cannot urge you strongly enough to go and check it out and spend some time having a look at it. There is a huge amount of stuff on there, as you can see, not just the manipulatives, but all sorts of question generators and starters and different tools that you can use to support your teaching and to work with your learners. And if you are interested in manipulatives and visuals and using them to support your teaching and support your learners in making sense of these mathematical ideas, then I would also suggest you check out my website, visiblemaths.co.uk. Amongst the many things you will find on there, you will also find a link to my book, which is also titled Visible Maths. And that has got a huge amount of supporting material for teachers who want to use manipulatives and visuals to help make sense. And on my website, there is a link to the publisher's website, Crown House Publishing, and they have some sample pages that you can view. And of course, they have a place where you can place an order if you think you would find it a useful thing to have. I will be making these videos throughout lockdown and potentially even beyond. So if there is a particular process, procedure, idea, concept that you feel like you would like to see modeled using manipulatives or visuals, then please do get in touch. I will add it to my list, and hopefully I will get around to creating it for you. Thank you very much for your kind attention.